Hello and welcome to my YouTube channel. Today I'm going to be going over the stations to be activity, and I will be explaining all the answers as well as addressing any potential questions that you may have. Alright, let's get started. So with the first station asks you to find the error in the student work. So these are direct student responses from your classmates. So if we look at the first one, the first student response is that the rate of change was 1, and they said that the real world meaning of rate of change is the change in y and change in x. It can be positive or negative. Okay, however, take a look at the graph on the right. So this is what this particular student graphed. They graphed the boxes going up 1 over 1, up 1 over 1. However, whenever we are graphing something, we need to pay attention to the y-axis and x-axis. What do you notice about the x-axis and the y-axis? You think you got it? The x-axis is going up by increments of 1. Okay? So the x-axis is going by increments of 1. The y-axis, every box is accounting for 30 miles, every box. So, if we look at the rate of change, is it actually 1? No, of course not. It has to be 30 over 1 because we rise up by 30 miles and run to the right by 1 gallon. So what this student forgot to do was they forgot to account for the increments on the y-axis. And the real world meaning of rate of change we have to talk about because this shows up on the Regents every single year. On the Regents every year, they ask you to talk about the real world meaning of something, whether it's rate of change, y-intercept, and so on and so forth. So we need to talk about how for every 30 miles that you drive, you are going to be using 1 gallon of gas. Alright, hopefully that clears that up. Let's take a look at 2A. So we have calculate the slope of the line for the table. Graph and set of points to the right. Alright, so we want to determine if it's positive, negative, 0, or undefined. And let's see what the student did. So this student did 5 over 10 is equal to 1 over 2. Okay, so they have over here on the right that x is increasing by 5 and y is increasing by 10. Okay, great. So we do know that slope is the change in y over the change in x. So if slope is the change in y over the change in x, well, look at what this student did. They did 5, which are my x's, over 10, which was my change in y. This is backwards. You have to do the change in y over the change in x. Okay, so this answer should have been 2. Moving on. Alright, so number 3a, we have the student graph the following. So if I zoom in here, we have y equals 5. Okay, so for y equals 5, this student said this was going to be a vertical line. So when y is 5, does that make sense? When y is 5? Because look at it over here. When I walk from the origin all the way by 5 units to the right, that's when x is 5. So the error that we made was that we graphed this wrong. This should have been a horizontal line. This has a 0 slope, right? Remember we talked about this? I could technically rewrite this as y equals, there is a 0 slope, so there's technically a 0 out front of that x, even though you don't see it, plus 5. Okay, that's another way we can look at this. There is a 0 slope here. Alright, let's look at x equals negative 4. So when x is negative 4, this student went down on the y-axis to negative 4 and graphed a horizontal line. So again, this was graphed incorrectly. This should have been a vertical line. X equals negative 4. These are all of the values where x is negative 4. All along here. Okay. Also, the student forgot to label. Do not forget to label. Okay? That's a point on the Regents. Alright. Let's take a look at 4a. So with 4a, this is what one of your peers had graphed when they were working on this problem for homework. Okay, so your peer has the following work on their page. They're starting at the origin at 0, and they went up 1, 2, 3 over 2, up 1, 2, 3 over 2. All right, so let's check this out. Well, first off, we need to know what the slope is. So what is the slope? Slope is m. Okay, good. But what is it? Yes, it's going to be -1 divided by 3. Okay, and then the y-intercept? Very good. Y-intercept is going to be +3. So I should be starting, and you can actually see here, one of your peers actually has a dot initially on the 3, and then maybe they might have gotten confused and then brought it back down. Okay, so the y-intercept is 3, not 0. The slope is -1 over 3, meaning we're going to fall by 1 and then run to the right by 3. So over here on the right is where I have this correctly graphed. In addition, this student forgot their table of values. How many points do we need? How many points? 3. Yes, very good. We need 3 points. Do not forget your values. All right, so we have our label. We've got our graph. We've got at least 3 points. Remember, I've always said at least 3 points. And we have the table here. Great. Fantastic. Moving on. All right, so station 2. Station 2 required us to use our calculator. So now this is important. I've already talked to you about how a majority of your Regents exam can be done solely if you know how to use your calculator correctly. So for question number 1, okay, we have 3 different graphs that have a positive slope here. I want to know which of these has the greatest rate of change. Another word for greatest rate of change, or just rate of change, is just slope. Okay, so another word for rate of change is slope. So I'm trying to find, well, which of these has the greatest slope? Very good. Right here. Right here. This has the steepest slope. Okay, and how do I know that? How do I know that this is the greatest slope? Because it's the steepest slope. So this first graph right here is our steepest slope. What happens as the positive slopes increase and get bigger? Well, we kind of just already talked about this. So if we look here, this is where y is equal to y is equal to a half x plus 1. So that's here. And then right here, when y is equal to x plus 1, that's this line. So you can see, as we go from blue to pink to green, the slope is getting steeper, okay? We're increasing. All right, let's check out number 2. Hopefully that clarifies up here. All right, so very similarly, again, as we go from left to right, you're going to be decreasing. You're going to be decreasing. So all 3 of these equations have the exact same y-intercept. The slope of -2. So the slope of -2, well, that's right here. Okay. The slope of the line with -2. Okay, that's the steepest slope. The least steep, I'm going to highlight that in green. That's our least steep. Ooh. Least steep slope. Okay, so as the negative slopes decrease, as we decrease, so I go from -0.5 to -2, the slope is getting steeper. All right, let's take a look at 3, 4, and 5. All right, so with number 3, all of these graphs I'm telling you have 0 slopes. Remember, 0 fun, 0 slope, that's horizontal. So all of these lines have a 0 slope. How are they all related? 0 slope. Horizontal lines are when we have y equals a number. That's really important, very, very important. Okay. All right, 4 and 5, as discussed in class, are 2 of the most important calculator errors to address. I've been seeing this a lot from you all. Or not everybody, but a good chunk of you. Okay, so if we look here, I'm asking you to find the slope given these 2 points. And the student writes this down. Okay, this is written correctly, so there's nothing wrong with the way this is written. They have their y2 minus y1 over x2 minus x1, and they just substitute it in. Okay, so identify the error. So if the error is not here, well, it has to be something in the calculator. Let's check it out. Okay, so we have 7 minus 0 divided by negative 5 minus 9. Okay, well, I mean, that looks good. That's typed in correctly, right? Gotta be. No! The answer should be no. We are missing parentheses. Oh my goodness. Oh my goodness. We need parentheses. I cannot stress this enough. Do not get a question wrong because you forgot parentheses in your calculator, but you did all the hard work on your paper. Okay. Parentheses. Let's see what's going on with number 5. Student is asked to find the slope given the following 2 points. Okay, again, this is written correctly. This is written correctly here. This is good. So let's see what's going on in the calculator then. Let's check it out. Okay, I have positive 5 minus negative 4. Yep, that looks good. And it's being divided by 2 minus 2. Oh, okay, great. So we have parentheses here. Right, so we're good? We're done? I do have my parentheses. So there can't be an error, right? No, 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 no. We're missing our parentheses here. Oh my goodness. Parentheses, parentheses. Okay? Please, please, please make sure we're double checking your work. Please, please, please. All right. That is enough time spent on station 2. Let's take a look at station 3. So station 3, which of the following values is part of the solution set of this inequality? Okay, so again, I talked about this with you all in class and how this was a common mistake being made on our tests. So when we distribute that negative 5, I'm left with negative 5x minus 50. I brought the 50 over to both sides. You have to cancel these out. Negative 5x is greater than 45. Okay. Well, I'm dividing by a negative. What am I supposed to do when I divide by a negative? Oh, yes, that's right. I have to flip the inequality symbol. Notice how the inequality symbol here flips. It went from greater than to now less than. Okay, so x is less than negative 9. Awesome. That's my answer, right? We're good? OMG, no. OMG. No, no, no. Wait a second. Hang on, Ms. Tomei. I need to go back and make sure I read the question. I'm asking which of the following values is a solution. I need this to be a solution. Okay. Well, give me an x value that's less than negative 9. Is negative 9 less than negative 9? No. Is negative 7 less than negative 9? Nope. What about 0? Nope. So by process of elimination, has to be answer choice D. Okay. Negative 15 is less than negative 9. That checks out. We're good. All right, moving on. Moving right along. So we have Shelley is trying to place square root of 47 in simplest radical form. So what do we want to enter into the calculator? We have to remember that we want to type in the number that's underneath the radical. So you are not typing in square root of 48 divided by x. You're just typing in 48, the number under the radical, and we're dividing it by x. We're going to look for the largest perfect square. So in my calculator, I'll see 16 and 3 in my table. I'm going to put them both under a square root. Both go under a square root. This is so important. You need the square root. Okay? Square root of 16, that's just 4. Square root of 3, that just stays the square root of 3. Can't simplify that. Square root of 16, 16 is a perfect square, and we're done. Okay, real quick over here, question number 3, we've got What is the result when this is subtracted from this? Okay, we have to remember that from comes first. So I should have this first, my x squared plus 2x minus 5, and then 4x squared minus 7x plus 8. I've got a little negative out front here. I'm going to have to distribute the negative, because technically, I have a little -1 out front. So I can distribute that negative into every single term. Alright, so degree of the polynomial, we've talked about this before. That's always going to be the highest degree, the highest exponent in the polynomial. So that's 2. The leading coefficient, okay, leading coefficient means the number out front of the term with the highest degree. So that would be the 4. That's our 4. And then I have, what's the constant? Okay, well, the constant term is just the number without a variable, so that's our 13, -13, sorry, -13. Yes, please be careful of that. You cannot forget the negative sign, otherwise that's wrong. You need the negative. Alright, so far so good. We're chugging right along here. Alright, so my next equation, I'm asking you to solve for y. Okay, so I want to bring over this -7x, so I added that to both sides. How do we undo subtraction? Addition. Alright, so I added 7x to both sides. I'm left with -14y equals 7x plus 28 divided by -14. I want to then get y by itself, so the operation between -14 and y is multiplication. How do we undo multiplication, Ms. Tomei? Yep, you got it. We divide. We're dividing by -14 on every single term. And then this is just my answer in simplest form. I just simplified everything completely. So far, so good? Awesome. Alright. Number 1a. So I give you the following equation for Fahrenheit F in terms of Celsius C. And we have F is equal to 9 over 5C plus 32. Solve the literal equation for C in terms of F. So I know that some of you were getting a little confused about this part right here. Solve for C in terms of F. All that means is just solve for C. Okay? Just solve for C. If that's what you want to write to remind yourself, all you're doing is solve for C. That's it. Okay. So by solving for C, I first brought over my 32, brought that over. To undo addition here. To undo addition, I had to subtract. Then I decided to look at the multiplicative inverse of the 5 in the denominator. So 1 over 5, the inverse of that would just be 5 over 1, so I multiplied both sides by 5. After that, I then distributed that 5 into the F and to the -32. And then I divided by 9 on both sides, and I left my answer as is right here. So all I wanted you to do was just solve for C. That's it. Don't make it more complicated than it needs to be. Leave your answer as is. Alright, so using your equation from part 1a, you need to make sure you read directions. I'm telling you, use the equation. Do not come up with a new equation. You just got one. You just made one. Use it. So using this equation, what is the value for degrees Celsius when Fahrenheit is 84 degrees? So all I'm doing, guys, I'm just plugging in 84 for F. So F right here, I'm just plugging in that 84. And then I'm going to solve for C, and I get 28.8 repeating degrees Celsius. Alright, moving right along. We've got Harrison and Griffin at Six Flags, and they want to ride the Superman ride. However, there are measurement requirements. So in order to ride the Superman ride, you have to be at least 45 inches tall, but no more than 58 inches tall. So what's this inequality going to look like when graphed? Well, we need to make sure we understand that at least is the greater than or equal to sign. And no more than. Okay, so think about this with money. Okay, say I'm going to the grocery store and I can spend no more than $20 on groceries. I could spend $19 on groceries. I could spend $20 on groceries because I'm spending no more than the 20, but I could not spend $21. Okay? So no more than, that's your less than or equal to. We need to make sure we know these keywords. Keywords, very important. At least and no more than. Okay? So when I graph this, I'm just graphing this between 45 and 58 with a closed hole. Closed hole because we have the equals to piece in both of our inequalities here. Okay. Continuing, we want to know if Harrison is 50 inches tall. So if Harrison is 50 inches tall, is he able to ride the Superman ride? And you need to justify. So you cannot just say yes. That will not get you any credit. You need to explain. This is the most important piece, and some of you like to overlook this, but you need to explain. Okay, so your justification is going to be that 50 is in the solution set. Since from 45 to 58, 50 is in between there. That works. Similarly, we have Griffin is 58 inches tall. Is he able to ride the ride as well? We have to find out, and you need to justify. You cannot just tell me yes. That gets you no credit. All right, so we just talked about this. No more than means including the 58. So if Griffin is 58 inches tall, then yes, that number, that value is in the solution set. He can ride the Superman ride with Harrison. All right. Alrighty. We've got the back page of this station. Okay, so all I did was ask you to graph the equation on the set of axes. So we want to make sure we label, and you have your table of values. 3 is fine, so if you want to just give me these 3, totally fine. We need to ask ourselves, is the point 0,6 a solution? What does it mean for something to be a solution to the equation? Yep, I think I just heard someone say it. It needs to be a point on the line. Okay, so let's check this out. Is 0,6, let's label that. 0,6. So I have 0 and then up 1, 2, 3, 4, 5, 6. That's right here. Is that a point on the line? Nope. So is 0,6 a solution? Of course not. No, it is not on the line. We're done. Moving on. Consider the following inequality. So I have x is greater than -3. Okay, x is greater than. We need to know, is this going to be an open circle or a closed circle? Good, open circle. Open circle because there is no equals to piece. Okay, so we have our open circle. And remember what I talked about with you in class. So remember I said as long as we have the variable x on the left-hand side, right? So if I have x is greater than -3, as long as x is on the left-hand side, I can draw my arrow indicating the direction that we're shading. Again, that will only work for when you get the variable on the left-hand side. All right, so the real-world meaning of this is that x is just going to be greater than -3. Now, if you need to star this on your page, please do. Is the value of x equaling -3 going to be in the solution set? Again, if you just write yes or no, that gets you no credit. You need to explain. So again, is -3 right here, is that going to be in the solution set? No, it cannot. It cannot be in the solution set. Why? Because -3 is not greater than -3. That is not good. Don't fall for the trap. All right, station 5. So let's take a look at station 5. I asked you to graph these 3 lines with the same exact slope. I added in this +0 right here just because I just wanted to remind myself that the y-intercept here is 0. So here are all 3 of my graphs. And what you should hopefully have noticed, if you didn't already, is that all of these graphs are parallel to each other. Parallel lines, and this is up and coming. Notice this is our looking ahead topic. Parallel lines never intersect. Parallel lines never intersect. Okay, so I have that right here. State a rule. You can write down that parallel lines never intersect, and they are lines with the same exact slope. Okay? All right, hopefully, I mean, and again, that should make sense. If there are 2 things that are parallel to each other, they're never going to touch. All right, question number 2 here. I have graph the following equations on the set of axes. So again, you could only, if you wanted to, you could only give me 3 points if you want. I need at least 3. Okay, I need to label. You need to label. Okay, so I'll highlight the green here is this graph, this line. Okay, the pink here is this graph. Make sure you label. Okay. Oh, let's pick a different color. It might be a little hard to see. Let's go with maybe that yellow. Okay, yeah, a little bit better. All right. So, when we graph these two things together, what do you notice? What is a point in the solution set? Again, I cannot say this enough. You need to justify. You need to. Otherwise, you're not getting any credit. You have to do your best. All right, so since both of these lines are going to intersect at this point right here, and again, this is up and coming, at the point 1, 3, that's a point in the solution set. Notice here, when I graphed y to equal x plus 2, there's a point. When I graphed y equals negative 2x plus 5, there it is again, 1, 3. There's my intersection point. They both share this in their solution set. Okay, so my solution set includes 1, 3. All right, looking forward. We're almost there. We're almost there. Keep holding on. All right, so we talked about this briefly. I've done this in a few different do now activities with you, but we haven't gone into too much detail on this, so I want to address this now and see what you remember and going forward. So, an example of set builder notation. Do not get all wrapped up and concerned with all of these. You have the curly brackets, you have what looks like an absolute value bar, but that is not an absolute value bar. And then again, curly brackets. So all you need to know is just look right here. Right here. All this is saying is the set of all x values such that x is greater than 0, all we really care about is x is greater than 0. Done. That's it. Okay, so if I come over here, how would I graph x is greater than 0 on a number line? Again, if you remember from class, as long as the variable is on the left-hand side, I have x is greater than 0. I can draw in my arrow in the direction of where I'm shading. So I'll be shading to the right. If I look over here, I'm given again in set builder notation. You'll hear me refer to set builder notation and interval notation. So set builder notation is here. Interval notation is down here, and we're going to get to that. All right, so with set builder notation, again, all we need to pay attention to right now is right here. X is less than or equal to 2, or x is greater than 3. Okay, so I'm going to create my closed circle on 2, and I'm going to create an open circle on 3, since there's no equals to piece. Okay. Well, again, let's check this out. As long as x is on the left-hand side, so I have x is going to be less than or equal to 2. Okay, that's one of them. Or, okay, I have x is greater than 3. So now notice my variable's on the left-hand side, so this is going to work out perfectly. Let's see what happens when I draw on my arrows. So I'm going to draw on my arrow here. All right, so when x is less than or equal to 2, I'm going to be shading to the left. And when x is greater than 3, I'm shading to the right. So we do not shade in between. We're shading in both opposite directions. So I'm shading to the left, and then I'm shading to the right. Okay, use these arrows techniques to help you out. All right, lastly, we're looking at interval notation. We are almost done with this video, your first ever broadcasted video from Miss Tomei Live. Okay, so we have, how would I graph? Again, this is a square bracket with a comma, a comma in the middle, sure. So we have square bracket 3, comma 5 with parentheses. So the square bracket means including. So a square bracket, that's going to get a closed circle. Whenever I see a square bracket, I'm thinking closed circle. Okay, that's going to get a closed circle. If I have parentheses, so if I have parentheses, which are right over here, I'm going to be thinking open circle. Open circle. Okay, so open circle for parentheses. Okay, so if we look over here, how would I graph from 3 to 5? And you'll hear me refer to inclusive, exclusive. Okay, so 3 is included, so I'm going to have my closed circle. We just talked about that over here with the square bracket. All the way to 5, but not including 5, so there's my open circle. Okay, let's look over here. Given the following in interval notation, I'm going from negative infinity to 12, and I'm including 12. So 12 is going to get the closed circle. And check this out. We're looking to go from negative infinity to 12. Well, that's going to be every single number that's less than or equal to 12. Right? I can go 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, etc., all the way to negative infinity. These are equivalents. Okay? Alright, I'm just going to highlight that here for you. This is equivalent to this. Alright, let's look at this last one to wrap up this video. We're given the following in interval notation, 9 going on to infinity. That means that x is going to be greater than 9. So notice how 9 has the parenthesis around it. That means I'm not including 9. Notice the open circle when we have 9. Okay, that means every single value greater than 9. So I have 9, 10, 11, 12, 13, 14, 15, 100, 200, etc., all the way to infinity. Okay, that's all that there is to this. Hopefully I helped clarify any misconceptions or questions that you had. And I will see you tomorrow in class. I hope you enjoyed this video. Alright, thanks. Bye.